Hello, everyone, and welcome back. I'm Mr. Cobalt, and today we're going to start to go over problems that require or are asking you to find the empirical formula. And so in this video, I'm just going to go through the steps that you want to go through, and then one simple example following each step so you can get an idea of what to do. Okay, so if you run into a problem that's asking you find the empirical formula for a substance, they got to give you some sort of information. Sometimes they will give you the mass percent of the substance. They might tell you what the substance is, or maybe it's an unknown. But they got to give you some information about the individual elements in the compound. Okay, so the first step is whatever information they give you, you want to convert that to grams. Your goal in these formulas, since they want to find an empirical formula, you have to remember that the empirical formula is the formula of the substance that is the lowest whole number ratios. So if you remember, so for example, water, H2O, this is the actual formula of water, but you'll notice that the 2 and the 1, H2O, it's already in a 2-to-1 ratio. That's the lowest whole number ratio you can get, so it's already in the empirical formula. And my example before was H2O2, hydrogen peroxide. This is a 2-to-2 ratio, so this is not in the empirical formula, because the empirical formula, by definition, is the formula with the lowest whole number ratio. So 2-to-2 can be reduced to 1-to-1. So the empirical formula for hydrogen peroxide is HO. So we're looking for the lowest whole number ratio between the elements. And that's going to be a mole to mole ratio. So your ultimate goal is to get the element data that they're giving you, the information they're giving you about the elements in your compound, into moles. And then what you want to do is, once you get the moles of each of the elements, you're going to then want to get a ratio, a whole number ratio between them. So first, when you convert to moles, they're not going to be nice whole number ratios. But then what you're going to do is you're going to make a ratio between them by dividing or relating the others to the one that's smallest. And so you'll end up getting a ratio of 1 to some number related to the others. So the first thing you want to do again is, if they give you something like mass percent of each element, then you want to convert that to grams. So all you do is you assume out of 100, and then you just make whatever number of percent that they give you, you just make that the number out of 100 grams. So if they give you 60% of carbon, for example, then that's going to be 60 grams out of 100. So you just change it to 60 grams. And then same thing with the other percentages. So the percentages of the elements that they give you should add up to 100%. And so you assume everything out of 100 grams. And so you just change the percent that they give you to a gram amount out of 100. If they already give you grams, then you already have grams. So there's nothing to do in the first step. The second step, once you have grams, again, your goal is to get the moles. So once you get grams, you can use the molar mass. So convert to moles using molar mass. So, and then once you get moles, then what you're going to do is you're going to create a pseudo formula. So you're going to take whatever moles you got and you create a formula. So let's say I have carbon, hydrogen, oxygen. I'm going to just take the moles that I calculated from this step here, when I took my grams and I took the molar mass and created moles. I'm going to take that, I'm going to write it here as X, Y, and Z. And these are not going to be nice whole numbers. They're going to be like they're going to be decimal numbers, right? So it could be like C to the 0.1 0.1526, and this might be h to the 0.0315, and Z might be, or oxygen might be 0.0315 or something like that. So you'll get these ugly numbers. That'll be your pseudo formula. And then what you want to do, once you get your pseudo formula, is you want to create a ratio. Notice that they're not whole numbers. So you can create a ratio, a molar ratio between them by dividing each of these by the smallest one, right? So that's the same. If you divide by the smallest one, you're basically creating a relationship or a ratio between the smallest one and the other two. So if I divide by 0.0315, which is the smallest one, right? So that'll be, so this becomes 1 to 1, right? And then this is also 0.0315. That becomes 1 to 1. So then the ratio between hydrogen and oxygen will be 1 to 1. And then I'll get some number when I divide by 0.0315, right? So maybe this might be 5 or something close to 5. If I calculate that out, let's see, oops. So 0.1526 divided by 0.0315 equals, and I get like 4.844 or something like that. So I get some sort of ratio, and then once you divide, so that's step 4, divide by the smallest number. Then once you divide, you might have whole numbers here. So something, if you get something really close to a whole number, like 0.99998, or you get something like 2.99999, 8 or something like that, you can round to the next wholest number because it's pretty much the whole number. If you look at after you divide, if you get like a number that's like 1.5 or something really close to 1.5, like 1.4999, you could round that to 1.5. Don't round it to 2. That's just that's too much of a rounding error. Instead, if you get something like 1.5 for one of them, let's say I get 1 here and I get 1 here, and let's say for this one, let's say I got like 4.88 or something like that. You can let's like make that 0.5 just for the sake of argument. If that was 0.500 or something like 1, then you can round that to 4.5. If you get something like that, then what you need to do is, last step is you multiply by a factor to get rid of the 0.5. So the 0.5 is 1/2. So this would be the same as 4.5. So you multiply to get rid of the denominator, the half. So you multiply by 2. But remember, you just created a mole ratio between these. So it's 1 to 1, 1 to 4.5. So to keep that ratio, you multiply everything by that factor. So if I multiply by 2 to get rid of the half, then this will become 9. But then I got to multiply these by 2. And so this becomes 2 and this becomes 2. So then the mole ratio is 9 to 2. Same thing if you get something like really close to an obvious fraction. So if you get something like 0.75, if you get something close to 75, well, that's obviously 3/4, and so you would multiply by 4. Or if you got 0.33333, or that'd be 1/3, or 0.66666, or something very close to that, that would be 2/3. So you multiply by 3 to get rid of that. So most of the time, it's not going to be something complicated. It'll probably be something very close to a half, or 4.5, or 2.5, or 3.4999. So round that to 0.5, and then multiply by 2 to get rid of it. So you multiply everything by 2, and then once you get rid of that fraction, you now have your whole number. So this would be C9H2O2, right? So for my hypothetical example. So I hope that is clear. So we'll go over a quick example problem that I have here. So here I have an example where you decompose water, and you decompose a sample of water into hydrogen and oxygen. You get 0.857 grams of hydrogen, and you get 6.86 grams of oxygen. So that's the data they're giving you. So my first step is to convert what you are given to grams, but they already gave me the breakdown of my substance into grams, right? So then what I do is I now can take the gram amount. So I'm going to take the gram amount and I'm going to convert that to moles. So I have 857 grams of hydrogen. I'm going to put that over 1. I'm going to multiply by the molar mass of hydrogen. So that's going to be 1.008 grams of hydrogen for every 1 mole of hydrogen. Moles on the top, because I want to convert to moles, because I need the moles to create my pseudo formula that's going to give me a mole to mole ratio. So then I figure out what the moles of that is, and I do the same thing with my oxygen. So I say 6.86 grams of oxygen, put it over 1, and I multiply by the molar mass, grams on top, so I put grams on the bottom, 16.00 grams of oxygen. 1 mole of oxygen, grams of oxygen cancel out. Now I have moles. And so now I use my calculator really quick. So 0.857 divided by 1.008 equals, and I get, here I get 0.850, let's say 2. And then this one I get, let's see, 6.86 divided by 16 equals. And this one I get 0.4288. Okay, so this is moles of hydrogen, and this is moles of oxygen. Okay, so now I have my moles. I'm going to write my pseudo formula. So here I'm going to write H, and I got 0.8502, and oxygen is 0.4288. Okay, so now obviously these are ugly numbers. I want whole numbers. So what I'm going to do now is I'm going to divide by the smallest, so I can get I can try to get a whole number ratio. I'm going to get a ratio between these two. So by dividing by the smallest, one of these is going to be 1, so it's going to be a ratio of 1 to something, right? So 0.4288 is the smallest, so I'm going to divide both by that one, 4288. That's going to give me a ratio of 1 to whatever this is, so 0.4288. So I take that number, 0.8502 divided by that one, 0.4288 equals, and I get 1. So then H becomes 1.9829. Oxygen becomes 1. Now 1.9829, that's really close to 2. That's close enough. I'll just round to 2. You can just round to 2. So that's H2 and then O1. You don't need to write the 1. So then this becomes, once I get the whole number ratio, I'm done. So this is the empirical formula for water. So I hope that was helpful. If you like this video, share this video, like the video, make a comment section, subscribe to the channel, and ring the bell.